students, we have studied in the last class about different applications of first law of thermodynamics. Today we are discussing a topic, isothermal and adiabatic elasticity of a gas. Now you are familiar with the process, isothermal process and adiabatic process. So what do you mean by isothermal process? Isothermal process is the process in which temperature is constant, and adiabatic process is the process in which temperature, pressure and volume can change, but there is no exchange of heat energy. So what is meant by isothermal elasticity? Elasticity you may have learned in the properties of matter course. Elasticity can be defined using Hooke's law as this ratio of stress by strain. So what is the stress here? Stress is actually the pressure exerted on the gas. So pressure is the change in pressure. Here at the initial pressure P is increased slightly to P plus dP. So the change in pressure is dP. This is the stress applied by the gas. So stress is dP. Then what is strain? Strain is change in volume by original volume. So change in volume is dV. We know that the original volume is V and when pressure is increasing, the volume of the gas is reducing to V minus dV. So the change in volume is dV. So change in volume is dV divided by original volume is V. So elasticity can be written as stress by strain is equal to dP divided by dV by V. So this can be rewritten as V can be bring to numerator, so V into dP by dV. So ഇത് നമുക്കൊരു ഫെമിലിയർ ആയിട്ടുള്ള ഒരു ഡെഫിനിഷനാണ് ഇലാസ്റ്റിസിറ്റിയുടെ. ഇലാസ്റ്റിസിറ്റി ഈസ് ഈക്വൽ ടു സ്ട്രെസ് ബൈ സ്ട്രെയിൻ, ദാറ്റ് ഈസ് ഈക്വൽ ടു വി ഇൻറ്റു ഡി പി ബൈ ഡി വി. ഇനി നമ്മളിവിടെ കൺസിഡർ ചെയ്യുന്ന കേസ് എന്ന് പറയുന്നത് ഐസോതെർമൽ എലാസ്റ്റിസിറ്റിയാണ്. സോ ഇവിടെ ടെമ്പറേച്ചർ കോൺസ്റ്റൻ്റ് ആണ്. സോ എന്തായിരിക്കും അതിൻ്റെ കോൺസിക്വൻസ്? നമുക്കറിയാം ഇതിൻ്റെ ഇക്വേഷൻ ഓഫ് സ്റ്റേറ്റ് എന്താണ്? ഇക്വേഷൻ ഓഫ് സ്റ്റേറ്റ് എന്ന് പറയുന്നത് പി വി ഈക്വൽ ടു കോൺസ്റ്റൻറ്റ്. ദിസ് ഈസ് ദ ഇക്വേഷൻ ഓഫ് state of an isothermal process. So that means P is proportional to 1 by V. So what this means? When pressure increases, volume will decrease. So when pressure increases, volume decreases. So we have to put a negative sign, because volume is decreasing means change in volume is actually a negative value. So change in volume should be a negative value. So the expression becomes V into dP by dV, and there should be a negative sign which indicates that volume is decreasing with respect to increase in pressure. Okay, so for an isothermal process we have PV equal to K. Now we want to find dP by dV. So for that we have to take the differentials on both sides. So P dV plus V dP equal to 0. So from this we get P equal to minus V into dP by dV. So isothermal elasticity means that, or isothermal elasticity is actually equal to the pressure exerted by the gas. So this is the relation of isothermal elasticity and its relation with respect to thermodynamic variable. Next comes the adiabatic elasticity. So the definition is same, elasticity equal to minus V into dP by dV. So here what is the process? Adiabatic process. So in the adiabatic process there is the change in the equation of state. Here the equation of state is PV raised to gamma equal to constant. So we can take the differentials on both sides. So we get P gamma V raised to gamma minus 1 dV plus V raised to gamma can be taken as constant into derivative of P is dP equal to 0. So we can divide throughout by V raised to gamma minus 1. Then this term will disappear. Then we get P gamma dV plus dP by plus dPV equal to 0. So rearranging we get minus V dP by dV equal to gamma P. So the expression for adiabatic elasticity is gamma P. So this shows that adiabatic elasticity is actually gamma times its pressure. So in the earlier case we got isothermal elasticity is P, and here we obtained adiabatic elasticity is gamma P. So we can easily show that adiabatic process, adiabatic elasticity is gamma times isothermal elasticity. So comparing these two equations we can reach this expression, adiabatic relation between adiabatic elasticity and isothermal elasticity, and it shows that adiabatic elasticity is greater than as isothermal elasticity for same change in pressure and volume. Okay, so it shows that for similar change in pressure, there is larger change in volume for adiabatic process, because the elasticity gives the relation between pressure and volume. So if elasticity is more, the change in volume is more. So for the same change in pressure, the volume change is more for adiabatic process. So this is a small question asking for exam, the relation between isothermal and adiabatic elasticity, or show that adiabatic elasticity is more than isothermal elasticity. Thank you.